Hey guys, this is video 12.2. We're going to be talking about base basics now. So kind of the opposite of what we just talked about in the last video with the acids. You're going to see some things that are similar but different. So again, flashcards are going to be a great tool for you to keep track of the different properties. You need to know the general properties. You need to be able to kind of know the general rules. So utilize those techniques. If you need flashcards, ask me. I have plenty of index cards that I can give to you so that you guys can keep track of those. So 12.2 base basics, general properties of bases. This is found on table L. I'm sure you, by looking at table K, have seen that. They only give you 4 common bases. Again, those are the biggest ones that you will probably use a lot of, but really as we go through this, we'll talk about how to identify bases. So bases, they have a bitter taste. So acids are sour tasting, bases are bitter. So an example would be soap. I'm sure, well, I'm not sure, but maybe you've had your mouth washed out with soap before, like on A Christmas Story, like Ralphie did. I mean, or you've just, washed your hands and you've tasted it. They definitely do have a little bit bitter taste with it. They feel slippery. That's something you should be aware of and probably are familiar with, right? Trying to get the soap off your hands, otherwise you can't really grip anything. Bases also change the color of indicators. When we do our notes on indicators themselves, we'll talk about how they affect different indicators versus acids. They react with acids as well to make salts in water. So again, if you don't know that term, you have to know it. Make a flashcard for the term salt, guys, and kind of on the back explain what that means. We went over that in the last video, so if you still don't know it, go back and rewatch it. These also can be and are electrolytes because typically if they're going to act like acids and they're going to break up and split up as well. So electrolytes, again, they will split or dissociate. That's really the better term I should use. Dissociate into ions. Okay, and again, it's those ions, those charges that allow for electrons to flow that will let that current flow through, so we can have that current kind of going through and we can see the electricity. So have, I would say, a flashcard for those. Arrhenius base definition, that would be another flashcard that I would have as well, with the definition on the back and maybe the general rule for bases as well. So Arrhenius base, traditional definition, again, substance whose water or aqueous solution contains or produces OH. What is OH? You guys should know that name by now. Hydroxide. Okay, so acids are producing hydronium, that H3O+. Bases produce hydroxide. If you take a look on table L, guys, with the common bases, you've got NaOH, you have KOH, you have CaOH2. Okay, those are it's going to be a common theme with a lot of bases. Now there are exceptions, ammonia being that one, and they give you ammonia on table L, so you don't have to memorize it, but you guys are probably aware of that. And again, it's producing hydroxide as the only negative ion. Okay, so again, within a solution you can have you're going to have another ion, but this is the only negative ion, okay, when it dissociates in water. So the general rule of thumb for bases, again, not all of them, they contain OH at the end, okay, of the formula. One exception would be ammonia. Right, NH3, be on the lookout for ammonia. Ammonia is a base. We're going to talk about it. It's a weak base, but it's still a base. Now, another thing, guys, I want to talk about too are these things called alcohols. We're going to do more with it when we get to our organic unit, which is right before the Regents exam. But I gave you an example in the last video of methanol, right? That ends in OH, but it doesn't, it's not a base, okay? What we're going to talk about here toward a little bit later in this video is that those bases that end in OH typically are going to be with metals. Those are the ones you want to be on the lookout for. Okay, so organic pieces that are just all covalent, they're typically not going to be. There might be a couple of examples, but try to keep it simple. Okay, general rule of bases, rule for bases at the end, they end in OH. Okay. But we'll talk more about those specifics later on. And as we come across different regions questions, we'll address those more directly in class. So kind of a similar trend you're going to see here, like we had with the acids, where we had the monoprotic, diprotic, triprotic. We still have that same idea with bases as well. The first one is going to be a monohydroxy. Notice how that changes. Okay, mono is one, hydroxy means one hydroxide ion that is produced. Okay, so monohydroxy bases, they're going to produce one OH ion in aqueous solution. It's that single step. So for example, if potassium hydroxide split up, we'd get K plus, and we'd have OH minus. Okay, continuing along that line, we have dihydroxy bases. Don't overthink it, guys. You know what the prefixes mean. Hydroxy is referring to hydroxide. Di is two. You should know that by now, so try to keep it simple. You know, some of our definitions are not super complex. The words themselves will define them. So this is going to produce two hydroxide ions in aqueous solution. Oh, I forgot to change this. This is not a single step. This is a two-step. Okay. Oh, I'm sorry. No. Excuse me. Got sidetracked. No, it's still a single step, okay? Whereas acids, it takes multiple steps. These guys are going to just split right up, okay? They're ionic compounds, so they're going to split right up. That is the difference between bases and acids. My apologies for that. I was thinking of acids. So Ca2+, and we would have two hydroxide ions. Sorry, that should be on the outside. Remember, your charge should always be on the outside of your parentheses because it's shared throughout the entire substance. And the last one is going to be a trihydroxy base. It's going to produce three hydroxide ions in solution. Again, single step because these are ionic compounds. So aluminum is going to be 3+, and you would have three hydroxide ions. Now you might be asking yourself, can we have something like a quad hydroxy or a quad protic? No, guys, 3 is the most, okay? Because we're never going to have something that has a charge that's greater than -3 in terms of an ion, so that's the biggest thing you have to balance out. So there's nothing bigger than tri in terms of trihydroxy and triprotic. So again, not all compounds that contain OH are bases, alcohols and organic acids. We will do more with these toward the end of the year when we do our organic unit. So for now, you can assume if you see OH at the end, it's going to be a base, okay, for now. We'll talk again, like I said, more. When in doubt, it's probably going to be a base, especially if it's talking about anything with pH or hydrogen or hydroxide ion concentration or indicators. If it's something that has nothing to do with the acid-base stuff we're going to talk about in this unit, it's probably then the organic stuff. But for now, we're going to just assume that OH is a base. Okay. So a few other properties, kind of the types of bases. We've got strong and weak. Strong bases, and strong guys we're going to talk about, that means they completely dissociate. I want to show you guys a demo in class at some point where we're going to show the difference between strong and weak, okay? Completely dissociate means that 100% ions form, okay? So they always break down. This is true of acids as well. Strong acids are going to break down completely as well. So for bases, if you have a metal that's in group 1 or 2, so 1A and 2A, guys, it's group 1 and 2. So lithium, magnesium, beryllium, calcium, strontium, potassium, sodium, rubidium, strontium, barium, cesium, francium, radium, those ones, those 8, it's a strong one. So we could have NaOH, sodium hydroxide. I'm not going to write the names in, you guys can. We could have potassium hydroxide. We could have barium hydroxide, okay? So those ones are your strong bases. Weak bases are going to be the ones with transition metals and organic compounds containing nitrogen. So ammonia would be that example. This would be iron something hydroxide. What's the charge on hydroxides? A -1. So -1 times 3. Total of -3 charge. That means iron has to be 3. Okay. So weak bases, they do not dissociate completely. Okay, that means that there is still some of the substance that has not formed ions. Okay, it's still together as a piece. Okay, so it would be like, oh, some of your particles of iron 3 hydroxide would split up, but you would still have some that still stay together when they're in solution. Okay, again, as we go through, we will talk more about it. So a solution that contains hydroxide from a soluble base is referred to as alkaline. So you've heard of like alkaline batteries. Okay, hydroxide, that means it's alkaline, so alkalinity, things like that. This term anhydrous, okay, means without water. So anhydrides are acids or bases that have had water removed. Okay, they're no longer wet. So any oxide that will produce an acid when dissolved in water is called an acid anhydride. An example of that would be something like SO2. It would be CO2, N2O5. Notice these are nonmetal oxides, so nonmetals with oxygen. They are the ones that produce an acid. Any oxide that produces a base in water would be then called a basic anhydride. So examples of that would be something like Na2O, K2O, CaO, BaO. So notice how these are metals reacted with oxygen, so metal oxides. Just like a little rule of thumb, metal oxides generally form bases, non-metallic oxides form acids. Guys, this last part, you probably, again, I want to make you aware of this stuff. This is something that you probably won't have to know specifics of. Make sure you know this term anhydrous, though. That is something you very well could see on your region. So, until next time, I'll see you later.